Jai Hind to all. Myself Shikha Agarwal, Assistant Professor in IT Department at AKGEC Engineering College, Ghaziabad. So students, today we are going to discuss about one of the complex topic in computer networks, that is switching. When I am talking about a computer networks, the subject code for the university is KCS 603, and this particular topic is related to unit 1, because when I am talking about a network, in this case we know whenever we are creating a network, it is basically a set of connecting devices, and when we are connecting a multiple devices with each other, then we can say we are having a one problem, that how we can do the communication between them, how we need to connect them. So that is why on the basis of that, now the problem comes how to connect them, first thing. And whenever we are doing a connection, then we need to know how to make a one-to-one communication among the systems, how we can make it possible so that when n number of devices are connecting with each other, we can do the communication. So we know there is one solution to the certain problems, is first is point-to-point connection. As we have already covered the topics of mesh topologies, so we have talked about the point-to-point connection. In the case of point-to-point connection, suppose if I am creating a mesh topology, in that case each and every individual system is being connected through the wire or wireless with one another system. And the second way is we can create a star topology. Then we are having a one central hub and rest of the devices is being connected with that system. But sometimes if we talk about a large networks, in the case of large networks, however, it is very impractical, you can say, and wasteful when we are applying this particular concept of a point-to-point and a multi-point system to the network, right? Where we require a number and the length of the links is to be very much, due to which the infrastructure to be cost efficient, and simultaneously we have to talk about that most of the links would be ideal most of the time, right? So if I am talking about the different topological methods, so other topologies must employing the multiple connections also, due to which it is very difficult to maintain or to work beyond the capacity and the media of the equipments, right? So the better solution is switching. In the case of switching, we should know what is the definition of switching, how we can create a switched network, what are the different techniques, what are the different ways to generate a switched network. So before that, we should know what do you mean by the term switching. Basically, switching network, it is consist of a series of interlinked nodes which is called switches, and whenever we are creating a temporary connections, it is being applicable or it is being capable through the switches. So switches are the devices which is being capable of creating the temporary connections between the two or more devices which is being linked through the switch. And in the switched network, some of those nodes can be connected to the end systems. If I am using the word end system, it can be computers, it can be telephone lines, etc., right? But other are used for the routing, so that we can route the packet from one node to the another node. Fine. Now you can see the figure 1. This is a switched network. When I am talking about this switched network, you can check that A, B, C, D up to G, H, J, these all are the end systems. End systems, it means it can be a computer, it can be a laptop, it can be any other device through which we are connecting to the network, and this symbol is being used for the switches. So for creating this complete network, I have used n number of computer end systems, and simultaneously we are having a 5 switches. And through the switch you can check one thing, that suppose if I am talking switch 1, right? So due to this switch we are having a 3 connecting lines. It means it is having a 3 incoming lines as well as outgoing lines, right? So it means it is being connected through the 3 end systems, and simultaneously it is being connected through the 2 other switches also, so that we can create a link and we can transfer or we can send the data from one switch to another switch also, in which we are using the concept of routing. Now, let's talk about the taxonomy of a switched network. When I'm talking about the classification, you can say, or taxonomy of a switched network, it is being divided into the three categories. The first is called as a circuit switched network, right? Second is called as a packet switched network, and the third is called as a message switched network. When I'm talking about the packet switched network, basically it is being divided another into the two categories, which is called as a datagram networks and virtual circuit networks. Fine. See, if I'm talking about a circuit switch network, it is being working on a physical layer of the OSI model, and in the case of packet switching, it can work on a network as well as on data network layer, in which it is being divided into the categories, in which we can say, suppose if we are using a datagram network, it is being applicable on a network layer. If I'm talking about the virtual circuit network, it is being applicable in the data link layer, right? And the last, if I'm talking about the message switch network, basically this type of a networking, switching networking is least used in our current generations, in our current systems. Fine. Basically, it is based on the stored and forward mechanism. So, in this lecture, one after another, we are going to discuss about all these categories of switching networks. First of all, I am going to talk about the circuit switch network. When I am saying a circuit switch network, the circuit switch network is basically a network which is being consisting a set of switches through which it is being connected by the physical links. And whenever they are creating a connection between the two end stations, it is being creating a dedicated path. If I am using the word dedicated, it means it is being completely utilized the complete bandwidth or the channel capacity into the between those two stations made between two or more links. So, however, each connection use only a one dedicated channel of each link. And when I am talking about the link, it is normally divided into n channels, and it is being based on the concept of FDMA and TDMA, or you can say it is also based on the frequency division multiplexing and time division multiplexing, right? So, in this topic, we are going to discuss about how the circuit switch network works. It works in three phases. So, we'll discuss all these three phases. Then we'll talk about there is an efficiency and there is a delay into that network. And we know, if I'm talking about a circuit switch technology, it is being basically used in a telephone networks. So, first of all, we are going to discuss about a circuit switch network. If I'm talking about a circuit switch network, we can say it is a set of connecting switches by a physical links, in which each link is divided into n channels. Now, you can see the diagram. Suppose if I am talking about this one switch, right? Into this switch, we are having a n number of end systems, right? And after that, by using either an FDMA or TDMA, right? You can multiplex the data by using the single link, and data is being coming from the n number of channels. Fine. So, suppose this is the way how we have to create the complete circuit switch network. Now, after creating a circuit switch network, into this system you can find that there is an end system A and through the end system M. Now, we want to transmit the data between A to M and vice versa. Fine. So, into that case, there are n path which is being available to do the connectivity between A to M. Suppose the first path, if I say ki if it is being from A to 1 switched, then to the 2 switch, and then the 3 switch, and finally it reaches to the destination. One way. Second way, if I am talking about A to 1 switch, 4 switch and 3 switch, and finally we are reaching to the destination. So, it means we can say we are having an n number of paths, but in the case of circuit switch network, we have to create a dedicated path, right? If I am talking about the dedicated path, it means we have to create the path initially. So, that phase is called as a setup phase. Setup phase says that we have to establish the connection between both the end systems, which is being created as a dedicated path, in which all the resources like memory utilization, channel bandwidth, everything is to be dedicatedly exist between A to M, and during that time no other end system is having a right to transmit their data, right? So suppose from A to M, we have created this as a dedicated path, right? Now, in the case of circuit switching, if I am talking about a dedicated, it means all the resources is to be reserved during the setup phase. In the case of setup phase, all the resources is being reserved, and once the resources is being reserved, it remains dedicated during the entire duration of the data transfer until and unless we will do the tear down phase. Tear down phase is also called as a connection termination. Means we need to terminate the connection, right? So this phase is called as a tear down phase, right? Now you can see the diagram. Suppose if I am talking about a delay in the circuit switch network, right? Before we know how we are talking about the connectivity. Suppose there is a one end system, that is A, and we wants to transmit the data through the B, right? So into this system, they are connected through the two switches. Suppose this is switch 1, this is switch 2. They want to transmit their data from one end system to the another end system, right? So first of all, it will accept the first phase, that is called as a setup phase. When I am talking about the setup phase, in which they have to create a connection. So it will send a request for the connection establishment, and after receiving an acknowledgement from the opponent or from the receiver's end, then we can say we have entered into the setup phase. And into this duration, there is a certain amount of delay is being occurred, because the receiver is being the sender is being waiting for the acknowledgement, right? Then after that, once they have established the connection, all the data is being transferred through the dedicated path. And after creating that dedicated path, it means all the resources is being reserved for transferring the data from A to B. So after transferring the data, continuously they can transfer the data without using any type of an addressing or anything, right? Then in the last, if suppose they want to do the third phase, this is the second phase, right? Now if I am talking about the third phase, it sends a request to do the termination, so which is called as a tear down phase, right? In the case of tear down phase, once they are sending a request for the connection termination, and after receiving an acknowledgement, or directly they will send an acknowledgement. So in this case, they are doing the disconnection between the both the end systems. So due to which there is a delay, total delay between the complete system is to be increased, right? Now in this case, when I am talking about the circuit switching approach, the circuit switching approach basically is being applicable on a physical layer, in which it is also used in a traditional telephone network systems, where we are using the circuit switching approach. Now in this topic, this is the way how the circuit switch network works. Now let's talk about the second network, second system, which is called as a datagram networks. When I am talking about the datagram networks, you can see in the diagram, then when we are talking about the packet switched network, in this case, first of all, we are transferring the data in the form of packets, right? And when I am talking about the packet switching, it is divided in the two categories. First is called datagram network. The second is called as a virtual circuit network. So first of all, we are going to discuss about the datagram networks. As I have already told you that it is a one type of a packet switched network. So in the case of datagrams, these are called packets are called as datagrams. So in this, we need to send a messages from one end system to the another end system. If the message is going to pass through the packet switch network, in this case we have to divide the packets into the either in a fixed size or of variable size, and simultaneously the size of the packet is determined by the network and by using the certain protocols, right? And if I am talking about the datagram networks, in this case the packets are called datagrams. So in this we are going to talk about the first of all routing tables, their efficiency, their delay, and where we are using the datagram networks in the internet. So in the case of packet switch network, first of all, remember one thing: in comparison to the circuit switching, no resource reservation is to be taken place. Fine. There is no resource reservation. Whenever the user requires the resources, they are being allocated on demand. Clear? Then now you can see, first of all, I am talking about the datagram network switching. Now you can check there is an n number of end systems, and in the case of datagram networks, here we are using in the form of switches as a routers. Why? Because these are being applicable on a network layer. When I am talking about the datagram networks, as I have already told you that this we are using in a network layer, right? When I am talking about the network layer, it means each and every packet is being independently moved from the source to the final destination. They can route their packets from any node, right? From any switches. So suppose, for example, A generates a one message, and that particular message is being divided into the 4 packets, or you can say it is being divided in the 4 datagrams, right? So there is, and the end system is X. So after that, you can see, suppose this particular router is being here, we are having an n number of paths through which the datagrams can travel. Fine. So due to which it is being depending upon the datagrams that they all can follow the different paths as per their need, or as being followed the certain protocols. It is not mandatory for all the packets to forward or to move in a similar path, as we have studied in the circuit switching. Fine. So suppose packet is 1 is moving between router 1 to 2, right? Packet 3 similar, packet 2 is moving from 1 to 3, and packet 4 is moving from 1 to 4, and then from 4 to 5, and so on, right? Each and every packet is moving independently onto their route, and it is not mandatory that it is always reaching into the sequence on the destination. The most important is each and every packet routes on a different routes, and they have to be reached safely or securely into the correct destination. Now I have told you that when I am talking about the circuit switch network, datagram switching network, in this case we are using routers. Why we are using routers? Because routers help you to route the packet. Okay. So in this case, generally we have to maintain the routing tables. As you can see the diagram, that if this particular router I am talking about, it is having an n number of incoming and outgoing lines. So similarly, when I am talking about a routing table, so in this case we have to maintain the routers, and each and every router is maintaining their routing tables, in which they are using the combination of destination address and output port numbers. So for example, if the destination address is 1232, so it should be out through the port number 1, right? This is the way these are the routing tables is to be maintained in a datagram networks, and simultaneously these routing tables is to be updated periodically, so that whenever the system crashes or anything mishappens or new system is being added into the system, all of the router switches, they are aware about that particular changes into the network. So these routing tables is to be periodically updated. Now when I am talking about the datagram network, a switch in a datagram network, it uses the routing tables so that we can reach to the final destination addresses, right? If I am talking about the destination address, it means each and every packet in a datagram network, it always holds a destination address of the given node, right? And the destination address in a header of a packet in a datagram network remains the same during the entire journey of the packet, because in the case of OSI model we have studied that we have to use the destination address of the packet similarly into the same for the entire journey of that particular packet. Fine. Why? Because it is never used to be changed. Now you can talk about the delay in the datagram network. Suppose the transmission starts from A at time t is equals to 0, right? And there is a certain delay for creating a packet, whether it is enters into a queue or somewhere. Then when it comes to the nearest node, that you can say if I'm using a router, then again there is a certain waiting time, because router is already busy in sending others data and so on. There is a lot of chances to do it. Then after that to the next router and to the next router and so on. So if the packet is being generated at time t is equals to 0, and for example if it is reaching at time t is equals to 5, so there will be a total delay for approx 5 seconds or 5 milliseconds, whatever the unit we are using, right? So this is why we can say there is a delay into the datagram switching. When I'm talking about the switching in the internet of using a datagram approach, as I've already told you that it is being used at the network layer. Now we have studied about, one is a connection oriented approach, that is a circuit switched network, and the second we have talked about the independent movements, that we are need not to create a dedicated path. It means we have talked about the datagram networks, right? But there is a third category of a packet switched network, that is called as a virtual circuit networking. If I'm talking about a virtual circuit networking, it is basically a cross between a circuit switched network and a datagram network, and it is having the some characteristics of both of them, some characteristics of circuit switched network and some characteristics of a datagram switched network. Fine. And if I'm talking about the virtual circuit network, you can check, when I'm talking about circuit switch, it is being used on a physical layer, right? And if I'm talking about a datagram networks, it is being applicable on a network layer, right? So if I'm talking about a virtual circuit network, it is being applicable on a data link layer. Now, so first of all, the first thing is we always require a one type of an addressing, because we are moving the data from one node to another node. That is why we require a one type of an addressing into the network. And if it is having some characteristics of a circuit switching network also, so due to which it works in a three phases. The first phase is setup phase, then the second phase is data transfer, and the third is tear down phase. Then after that, we are going to talk about the efficiency of the complete system, how efficiently this particular network works, and is there any delay onto the system or not. And simultaneously, if I'm talking about the circuit switched networks, so technology, they are used in a wireless area, wide area networks, right? Now you can see the complete system of a virtual circuit network. These are the n number of end systems. It is being connected through the complete network, and they are connecting through the different switches. And this is particularly is a switched network through which all the switches is being connected, and they are maintaining the routing tables onto the system. Now, if I'm talking about a virtual circuit network, remember one thing, we always depend by using the VCI numbers. When I'm talking about a virtual circuit identifier, it is maintaining the different routing tables onto the system for their incoming and outgoing lines of a complete network. So you can understand the concept of VCI first. If I'm talking about the VCI number, for example, the data is coming onto this router or a switch, right? So if the data is incoming, then it always consists of one number. Okay, that includes a port address of that particular number. So if it is consist of VCI number 14, so its incoming VCI number is to be 14, right? The data which is being coming, the data which is coming from the VCI number 14, that is an incoming of that packet, it always goes through the VCI number 77. This is the way how it is being maintaining the routing tables of that data. Fine, which is having a various combination of the VCI numbers of incoming and outgoing packets of a data. Now you can see how the switched network works in the case of virtual circuit switching. See, for example, if I say the data coming from the port number 1, so we have to maintain the one routing table for incoming and outgoing, including the port numbers and their VCI numbers. So for example, if the data is coming from port number 1 having a VCI number 14, so this is an incoming data, right? And after that it is being outgoing through the port number 3 having a VCI number 22. So this is the way how we are maintaining the tables. Similarly, if the data with the port number coming from the port number 1 having a VCI number 77, it is being outgoing through the port number 2 with having a VCI number 41. This is the way how the virtual circuit network works. Now, as we have talked about creating a setup phase or 3 phases of the virtual circuit network also. So, into this case, first phase is called as setup phase. If I am talking about the setup phase, it is little bit complicated to understand. How? Because if I am talking about a network A, if this is the end system A, they wants to transmit the data system to the end system B. Fine. So, in this case, they have each and every switch, A is having a local switch as switch 1, and similarly the node number B is having their own switches on number 3. How they are creating the tables? First of all, the packet coming from the port number 1 is having a VCI number 3, for example, and whatever the packets is coming from the port number 1 having a VCI number 14, it always passes through the port number 3. Now the packet out from this port number. Then after that, when the data setup request comes onto the switch 2, now again it will check if the data is incoming from the port number 1, their VCI number is to be 66. Fine. Then after that, suppose if the packet is coming from this number, their port number is to be 66. Fine. Then after that, it is going to be outgoing to the port number 2, and we have to find their VCI number because we are not aware about the VCI number of that particular system. Then after going out from the second switch or the second outgoing port number, when it comes onto the switch number 3, in this case, when the port number 2 is there from the incoming, it is having a VCI number that is 22, right? Then after that, it is going to the particular system, and if this particular system generates the VCI number 77, fine, this phase is called as a setup phase. Now, after creating a setup phase, we have sent a request phase. In this case, this particular system is called as a request phase to know the VCI number of that particular system. Fine. Then after that, we have to send an acknowledgement. First of all, this particular table is being swept in the form of, this table is become incoming now, and this is becomes outgoing now, because we need to send the acknowledgement. So first of all, this VCI number is 77. So it will get filled here is as 77. So we have to check if the port number 3 is there. We have to send the data through the port number 2, and it is having a VCI number that is 22. Fine. Now the VCI number comes to the switch number 2. It will fulfill the table as 22, and it will again send the data to the port number 1 having a VCI number that is 66. And finally, when the data comes on the switch 1, then we have to fill the port number VCI number that is a 66. So this is the way how you are creating a setup phase. Now after creating the setup phase, let's talk about the data transfer. We know we have in the setup phase we came to know port number 1 is having a VCI number 14, outgoing for the port number 3 having a VCI number 66, right? So it will be incoming, then we have to create the outgoing by including the data as well as their VCI numbers. Fine. And you can easily transmit the data to the correct destination. Fine. Now after that, in the case of virtual circuit network, all the packets belongs to the same source and destination. They have to travel the same path, right? But the packets may arrive the destination with the different delays, because here we are not allocating the resources, or we are not creating a dedicated path. Here the resources is being allocated whenever we needs to demand on the resources. Fine. Now you can see, if I'm talking about the delay in the case of virtual setup network, there is a delay in the setup phase, because once it will create a request to generate the VCI number, and finally when we are reaching an acknowledgement. Fine. Then after that, when the data comes from the first switch, sorry, from one end system to the first switch, there may be a transmission delay, right? And then after that again, and so on. And finally there is a delay in the tear down phase also. Fine. So you can say this is the total delay is being generated into the complete network. So in this we have talked about switching, right? So in the case of virtual circuit switching technique, we are generally used at the data link layer in a switched wide area networks, which is being basically implemented by using the virtual circuit techniques, right? So we have talked about the two types of switching, circuit switching and packet switching. Now here in the last, we are going to discuss about the third switching, which is called as a message switching. Basically this is a technique which was developed as an alternative to the circuit switching before packet switching was introduced, right? In the case of the message switching, it was used earlier, but now it is not being used in a networks. In the small networks we can use it, but maximum times we are not using this type of a switching. In the case of message switching, end users can communicate by sending and receiving the messages that includes the entire data to be shared among them. And here the messages are the very smallest individual units in which the sender and the receiver, they are not directly connected with each other, right? So in which when we are transferring the data, in this case we are having a number of intermediate nodes through which we can transfer the data from one node to the another node. And finally we have to make an assurance that whatever the message we are generating, it reaches to the final destination. And the message switch network here is being called as hop by hop systems, or end to node to node delivery system. Fine. In the case of message switching, we are talking about the two important characteristics of the message switching. First is being based on a stored and forward mechanism. In the previous time I have already declared that message switching is a concept based on a stored and forward mechanism. So if I am talking about the stored and the forward mechanism, this is one of the important characteristic of using the message switching. In the case of a stored and forward mechanism, the intermediate nodes, they are having a equal responsibility of transferring the entire message from one node to the next node, and each node must have a storage capacity. By using that storage capacity, they can store the data or they store the message into their network, and message will only be delivered if the next hop and the link connecting it both are available. It will be stored definitely, right? So in the case of a stored and the forward mechanism or the switch, it will forward the message if and only if the sufficient resources are available and the next hop is in a ready state to do the accepting of that data. That is why it is being based on the concept of stored and forward property. First thing. Second, if I am talking about the message switching, it is called as a message delivery. In the case of message delivery, because we are wrapping up the entire information into a single message and we are transferring it from the source to the correct destination node. Each message must have an header that contains the message routing information, including the source and the destination addresses. Fine. Now you can see the diagram of the stored and the forward mechanism. Now suppose there is a one terminal laptop here, there is a mainframe, there is a terminals and mail servers. We have created a lot of network. And suppose this sends a one message to the switch 1. So into that case, when it comes to the switch and 1, it will do a storing and then forward it to the next system, then next system and so on. So that is why In the case of message switching, it is based on the stored and the forward mechanism. Now, in the last, we are going to discuss about the differentiation between all the three categories of switching: message switching, circuit switching and packet switching. So, the parameters, on the basis of the different parameters, first we are discussing about the applications, right? If I am talking about the applications of all the three, though in the case of message switching, it is being used in a telephone networks for the transmission of telegrams, right? In the case of circuit switching, it is also used in a telephone networks for bidirectional or real-time transfer of voice signals whenever we want to do the telecommunication in the case of circuit switching. But in the case of packet switching, we are talking about a internet for datagrams and reliable stream services between the different computers. Now the second parameter is end terminals. If I am talking about the end terminals means end systems. If I am talking about the end systems, in the case of message switching, it can be a telegram, it can be any type of a tele, right? But in the case of circuit switching, it can be a modem, it can be a telephone line. End system will be the computer system, right? Then after that, the third parameter is what type of an information you can transfer by using the different types of switching. So in the case of message switching, data can be in the form of Morse method, or you can say it transmits the data in the form of ASCII codes, right? Then after that, in the case of circuit switching, we can transmit the data or information in the form of analog voice or pulse code modulation digital voice signals. But in the case of packet switching, we always transmit the data in the form of binary information, right? Now, onto that, we have to talk about the fourth parameter, that is called as a transmission system. What type of a transmission system we are using in the case of different categories? First of all, I am talking about message. We are sending a digital data over any different transmission media. Now, in the case of circuit switching, analog and digital data over the different transmission media. And in the case of packet switching, digital data over different transmission. Now after that, we are going to talk about the addressing schemes. In the case of addressing, it is used for a geographical addresses. It can be based on a hierarchical planning numbering, that is being based on the numbers, right? And in the case of packet switching, it is having an hierarchical address spaces. Fine. And then after that, we are going to talk about the next parameter, that is a routing scheme. In the case of routing scheme, you can check in the case of message, as I have already told you that we have to create a message in which its header include the source as well as the destination address. So we have to create the messages manually. We have to create the routing scheme manually, right? Then after that, in the case of circuit switched network, before sending any data, we have to finally select the route which is being called as a dedicated path, and once we have selected the route during the calls, that particular phase is called setup phase, and simultaneously each and every packet moves from source to the destination by using the same route only, right? But in the case of packet switching, each and every packet is moving independently, right? Because we are transferring the data from one node to another node by using the independent movements. Each and every packet follows the different routes or the same route independently, right? And the last is, we are going to talk about the seventh difference, that is called as multiplexing scheme. If I am talking about the multiplexing scheme, in the case of multiplexing, in the case of message switching, multiplexing can be a character or a message multiplexing. We can multiplex the messages of n number of user systems. In the case of circuit switching, we are using a circuit multiplexing, and in the case of packet switching, we have to use the packet multiplexing shared media access network, right? So in this this table shows the difference between three types of switching techniques. So in this lecture, we have discussed the different switching techniques through which how we have to work, and each and every technique is having its own applications, as well as on which layer we are talking about the different switches, right? So one difference can also be created, that which type of a switching we can use on a different layers also. So this is one of the complex topic in computer networks. Thank you.